Hello, I'm going to present our work on automatic detection and correction of slouching utilizing electrical muscle stimulation. An outline of the presentation. I'll take you through the motivation for the research related works and finally a user study we conducted to investigate the performance of our automatic approach. Posture is the manner in which we support our bodies in different everyday activities. The alignment of our body parts supported by the correct muscular tension plays a crucial role in maintaining healthy posture. Repetitive actions such as prolonged sitting, standing, and use of computer systems are often the main factors contributing to poor postures, such as slouching, wrist extension, and neck cradling. Repetitive strain injuries, musculoskeletal injuries, increased stress, and low productivity are some of the effects of poor posture in the workplace. In USA, nearly $90 billion are spent every year for the treatment of repetitive strain injuries. Current intervention technologies only deal with detecting and alerting the user. These systems completely rely on the user's willingness and ability to correct their posture. EMS can be a way to correct posture through involuntary muscular contractions, and this presents an opportunity for the development of automatic poor posture detection and correction systems. EMS is a non invasive technique for delivering electrical stimuli to invoke involuntary muscular contractions. EMS has been traditionally utilized for rehabilitation and pain management. EMS has found new interest in HCI research primarily for immersive applications through muscular contractions based on computer feedback. Currently, HCI research has focused on EMS based systems for activity training, input output interfaces, and immersive technologies. This presents a gap in research for development of EMS based wearable intervention technology for posture correction. To detect and subsequently correct slouching, we developed a physiological feedback loop that relied on IMU sensors and EMS. The torso inclination and shoulder roll are constantly monitored for changes to detect slouch posture. When slouching is detected, automatic correction feedback is presented in the form of electrical stimuli to the rhomboid muscles to cause involuntary muscular contractions, which generates a pulling force in the opposite direction and thereby restoring upright position. We conducted a study with 36 participants. Metawear IMU sensors were placed on the deltoids and collarbones to detect slouching. EMS electrodes were placed on the rhomboid muscles and connected to a TENS device to correct slouching. In a 2 by 3 mixed design study, we compared our automatic approach against traditional audio and visual feedback systems and across two unique tasks, text entry and mobile gaming. We hypothesized that EMS feedback would have faster correction response times, deliver better user perception of correction accuracy and comfort, similar task disruption, and an overall better user experience compared to the visual and the audio feedback systems. Participants were required to complete all three modalities, the visual, audio, and EMS feedback. Each modality lasted 15 minutes. In the visual and audio feedback modalities, users were required to self-correct posture when visual and auditory alerts were presented to the user. In the EMS feedback modality, slouch posture was automatically detected and corrected by the EMS feedback. On an average, participants slouched 7 to 10 times in each modality across both tasks. The average EMS intensity required for correcting slouch posture ranged between 40 to 48 milliamps across both tasks. The average torso inclination angles range between 18 and 21 degrees, while the average shoulder roll angles range between 13 and 15 degrees for both tasks. In the mobile game task, EMS feedback was significantly faster than the other feedback types, while the EMS feedback was only significantly faster than the visual feedback in the text entry task. For our other hypothesis on user perception parameters, EMS feedback was perceived to be more accurate in the text entry task, just as comfortable and no more disruptive than the other feedback types. Overall user experience indicated that participants perceived all feedback types equally. Participants indicated a small amount of shared responsibility in aiding the automatic correction utilizing EMS. Participants also indicated that our automatic approach was interesting, and 20 out of the 36 participants preferred the EMS feedback, while 75% of the study population was willing to purchase a commercial posture correction device of this nature. The EMS-based automatic slouching correction outperformed the traditional feedback systems as they require self-correction, which places an additional cognitive load on the user while being engaged. Users perceived EMS correction to be more accurate as the other feedbacks often led to overcorrection. EMS was also perceived to be more accurate in the mobile game task in comparison to the text entry task. This may have been due to the nature and complexity of the tasks. Users exhibited a small amount of shared responsibility due to the availability of sensory confirmation in the EMS feedback. This indicated increased posture awareness and exhibited user involvement and adaptability. In conclusion, we designed and developed an automatic slouching detection and correction system using electrical muscle stimulation for improving human posture while being engaged in cognitively exhausting tasks. Our EMS-based system outperformed the traditional feedback systems with faster correction response times, better accuracy perception. It was equally comfortable and no more disruptive than the traditional feedback systems. Thank you.